The story of the origin of the Magaliesberg landscape is one of immense scale, of upliftment of the Earth's crust, of huge temperatures and pressures, and above all of a length of time that is almost incomprehensible. To try and understand that length of time, take an ordinary ruler, a 30 centimetre ruler, and regard each millimetre as being 1 year. So the South African War, for example, took place somewhere around here, between 110 and 120 millimetres ago. Mzilikazi's raid and his conquest of the Botswana was about 200 years ago. That falls about here on the scale. The hominids, whose skeletons are being found in the Cradle of Humankind by paleontologists, lived about 3 million years ago. So we would need a ruler that was 3 kilometers long, because there's 1 million millimeters in a kilometer. But the story of the origin of the Magaliesberg would need a ruler that stretches from here in the Magaliesberg to the island of Mauritius, 3 billion millimeters away, or 3,000 kilometers. Because it was 3 billion years ago that a part of the Earth's crust lifted and became the very first continent above sea level that ever existed on the planet. It's called the Kaapvaal Craton, and it lies under the northeastern part of the South Africa that we know today. More cratons appeared, and 400 million years later, the Zimbabwe craton collided with the Kaapvaal, pushing it back so that the sea invaded parts of the mini-continent. Rivers terminated at the receding shoreline, and gravel and pebble conglomerates, including small amounts of gold, accumulated at those estuaries. Today, those consolidated conglomerates form what we call the Black Reef, an inconspicuous elevated ridge along the southern edge of the Magaliesberg Biosphere. Here, at the confluence of the Crocodile and the Yuxke rivers, the prospector Pieter Jacob Moreer panned traces of alluvial gold in 1853. A small monument commemorates this, the very first gold strike in the Transvaal Republic. Moreer was sworn to secrecy by the Boer government, and it was more than 30 years before mines opened along the Black Reef, shortly before the huge and totally different Witwatersrand gold reef was discovered several kilometres to the south. In little mines like Kromdraai, Tweefontein and Blaubank, men worked by candlelight for 12 hours a day in narrow stopes that were barely large enough for them to crawl. There they dug with picks and shovels the narrow band of gold-bearing pebble conglomerates in the Black Reef. As the sea invaded further over the low-lying areas, a shallow lake developed over the large part of Kaapvaal Craton. Over the next 300 million years, lumps of bacterial slime called cyanobacteria evolved the ability to photosynthesize. Photosynthesis is one of the miracles of our planet. Using sunlight as a catalyst, carbon dioxide and water are converted into carbohydrates to stimulate the growth of the living cyanobacteria. A byproduct of this process was oxygen. Initially, all of the oxygen that was produced went to oxidizing ferrous iron into iron ore, which we mine today. But after many millions of years, free oxygen began to be released into the atmosphere and gave us the air that we breathe. Another byproduct of photosynthesis was calcium carbonate, which is essentially limestone. It encrusted the surface of the cyanobacteria and obstructed the photosynthesis process, so the slime had to repeatedly regrow over the calcified covering. Layer upon layer built up into what we call stromatolites. Their remains are still intact to this day, 2.5 billion years after they were formed, and this calcified material is the basis for a limestone rock called dolomite. It's a soft, dove-grey rock that takes on weird shapes as it weathers. So successful were the stromatolites that they built up the dolomite deposits on the ocean floor to a depth of up to 1 kilometre. and today they form the landscape of the southern part of the Biosphere Reserve and give us the cave lands of the Cradle of Humankind World Heritage Site. So now, perhaps for the first time in the universe, we had the four components that make up the biosphere: the rocks and the substrate of the lithosphere, the water of the hydrosphere, a breathable atmosphere, and life itself. As time progressed, silicon silt settled on the floor of the shallow sea and mingled with the dolomite, forming a fine-grained, blue-tinged rock called chert. Being much harder than dolomite, it remains prominent as the slightly soluble dolomite weathers away. Chert was one of the preferred materials for tool making during the Stone Ages. Stone flakes have been chipped away from this core to make arrowheads something like this. As the sandy sediments built up, they smothered the cyanobacteria, and layers of quartz gravel were interspersed with fine mud. More and more gravel compressed into a rock seabed of quartzite and mudstone shale, until a massive sandwich of sedimentary layers of quartzite and shale had been deposited several kilometers deep. Quartzite is the dominant rock formation of the Magaliesberg today. It's a hard, brittle rock that fractures along horizontal sedimentary layers and vertical fissures, forming sharp-cornered blocks. Where water flows over the sandy seabed, the ripple marks in the sand were set in rock and are still evident today. Shale is much more weatherable than quartzite and is usually fragmented and seldom exposed as an outcrop. Just over 2 billion years ago, an incredible event occurred that geologically sets the Magaliesberg aside from anywhere else. Just north of the Magaliesberg Biosphere, liquid magma welled up from below the Earth's crust and pushed vertically and horizontally through the seabed. Propelled by enormous pressures, it insinuated itself in dikes between the sedimentary layers and built up in a huge mass that cooled into the world's largest diabase lopelith, called the Bushveld Complex. The richest known deposits of platinum, manganese, chrome, and other minerals were precipitated around the edges and are now extensively mined along the northern boundary of the biosphere. The sheer weight of the diabase depressed the center of the seabed, tilting up the edges. And the uplifted southern rim is the Magaliesberg mountain range. The resilient quartzite seabed has retained its basic structure while the softer shale deposits weathered away into valleys. The edges of the rock bed have been broken off on the southern side to form sheer cliffs, while on the north, the surface of the seabed slopes gradually towards the Bushveld Complex at about 10 or 20 degrees off the horizontal. In places, the extreme temperatures caused the quartzite to metamorphose into feldspathic quartzite, with coarse, sugary crystals that are weathered away by wind and water into bizarre sculptures and mushroom shapes. The heat of the magma similarly metamorphosed much of the original shale deposits into slate and hornfells. A very important agent for weathering quartzite is lightning. Lightning strikes are frequent and severe in the Magaliesberg, and rock blasts can frequently be seen. It's unwise to hike in the mountains during those thunderstorms. The sedimentary rock layers of the ancient seabed were lifted up into separate parallel ridges with wide valleys in between. The deepest and furthest from the Bushveld Complex is the Black Reef. Next are the Dolomitic hills of the Cradle of Humankind. The rough chert rocks give the Skurveberg its name, and it's also called Kalkheuvel or Chalk Hill after the lime that was mined there. Further north is the ridge of quartzite called Witwatersberg, not to be confused with the Witwatersrand to the south. And finally, the Magaliesberg, the highest of the ridges, separated by a wide shale valley known as the Moot. The whole series of ridges that make up the Magaliesberg Biosphere Reserve were named the Bunkenveld by early Dutch settlers because of their similarity to rows of benches, or bunken in Dutch. North of the Magaliesberg, and beyond the boundaries of the biosphere, are mines and outcrops of igneous rocks from the Bushveld complex upwelling. The various types of diabase, norite, gabbro, rhyolite and others, are now quarried for tombstones and kitchen surfaces. Quite frequently one sees a double line of cliffs along the brow of the mountain. This occurred where a sill of magma separated two layers of quartzite, and the upper layer has weathered away more rapidly than the one below. After its violent birth 2 billion years ago, the Magaliesberg appears to have been undisturbed for almost another billion years. But then the Pilanesberg volcano erupted to the northwest of the Magaliesberg, and the scene changed dramatically. Rivers of molten lava flowed into fault lines in the Magaliesberg quartzite and burned deep canyons into the northern slopes. At Breed's Neck, the lava cut right through the Magaliesberg and is exposed on the southern side as a sharp ridge of syenite, which gives the village of Maanharont its name. But mostly the laval flow was arrested by the quartzite, and the resulting kloofs are scenic and natural gems, and the vertical walls are much loved by rock climbers. The kloofs are also an important source of quality water. High up near the summit, rainfall collects in pools where it is retained in spongy vegetation. From there it is released throughout the year and filtered through fissures in the quartzite to plunge over waterfalls into crystal pools and streams in the kloofs. The superb quality of the Magaliesberg water is one of its most important attributes. The altitude of the Magaliesberg is almost constant along its entire length, and this is because for more than 400 million years the continent of Gondwana drifted south towards the Antarctic. The Magaliesberg was dragged under the ice cap, and the peaks of the range were scraped off as the continent moved. Water played a very different role in the dolomite landscape to the south of the Biosphere Reserve. Dolomite rock is very slightly soluble, and at fracture points below the water table, the rock dissolved and caverns were created. The water table dropped, the caverns filled with air, and stalagmites and stalactites formed as calcium carbonate precipitated from dripping lime-rich water. As the surface eroded, sinkholes exposed some caves, and debris and occasional hominids and other animals fell into the caves. The debris and the skeletons, including those of human ancestors, became calcified into breccia, and the process of excavating them can be observed from this suspended platform in the Cradle of Humankind. But the caves were first excavated for lime in the stalagmites and stalactites. Lime was mined for use in the gold extraction process and for cement, and old lime kilns and furnaces are found near most of the caves in the area. As the supercontinent of Gondwana moved northwards from the Antarctic, the Magaliesberg became submerged under tropical swamp, and then later desert sands, as the region became hotter and drier. It was only after Gondwana began to fragment and Africa became a continent on its own that the sandy deposits were stripped away and the Magaliesberg was revealed as we know it today. The building of this landscape embraces almost the entire history of the world. The first continental landmass, the first biosphere of land, water, air and life, the tilting of a seabed to make a mountain, the birth of Africa, and the preservation of fossil clues to our origins. All of these factors make the Magaliesberg Biosphere Reserve one of the most incredible places on the planet.